Okay, we have a hypothesis test. That's a data problem. Everybody's favorite problem because we got to draw the box plots and write that horrible statement. You're welcome. All right, so as we move away from fluorescent and filament bulbs to power-saving LED lights or bulbs, I guess, but a lot of times they're not bulbs, they're just light. Anyway, it is important that these old tech bulbs keep their quality higher. They'll lose their customers forever. At a testing lab, the hours of 14 randomly selected 1,000 hour bulbs from last week's 15,000 or 1,500 bulb production run is listed below. And by the way, just if you're wondering how you had 1,000 hours with it being from last week, the machines that they run tests on don't run it as a 1 hour per 1 hour. The way that they run wattage through it is, and it's not exact science, but they pump extra power through it, and then they can measure it, and then they can determine how long that would last with a regular power. Not that you need to know that, but just thought I would say that for the heck of it. All right, so we get this list of values, and some of them are way under 1,000, see, and some of them are quite a bit above 1,000. And there's going to be a lot of variance in a light bulb. That's just the way it is. And surely you've had that before, where you have one light go out in your ceiling fan, and then the other one doesn't go out for a long time, and sometimes they all die at about the same time. So there it is. And I just, for the heck of it, I made one 1,000 exactly because I was bored coming up with other numbers for no other reason. But all right. So right here, it says, if we think that the mean bulb time is not 1,000 hours, we'll ship them internationally for no profit. What should we do with this shipment? So it already said if they're not high quality enough, they'll lose their customers forever. They'll spend the money and swap out LED fixtures and just use the LED bulbs instead, because it's easier and they last forever, but it's expensive to switch over. So basically, they're trying to make people not want to switch over by keeping their quality up. All right, so we're going to say the null and alternate hypothesis, and the null is going to be that mu is equal to 1,000. 1,000's the cutoff between what we think is the quality or not. And then mu is going to be less than 1,000. We're going to see if we have evidence that our quality is not adding up here, or not up to stuff. So we got the alpha. I'm going to get into that. So mu equals the true population mean. Getting used to writing those words out too, between true population proportion, true population mean. The true population mean hours of the 1,000 hour bulbs from last week's run. All right, and this is a one sample t-test for mu. Conditions, random, which we got taken care of, the 10% rule, which this one is not an assume this time, and that, just want to make sure we don't write that, and then large counts, and that's the one you're all waiting for, because we know we don't have 30, so we got to draw that box plot. Pretty exciting. So we have a random sample of 14 bulbs. Okay. All right, and 14 is less than 10% of 1,500 by a lot. And then the large counts, we're going to say, well, 14 is not greater than 30. So we look at the samples, not sampling distribution, the samples distribution. And then I'm going to get that in just a second, but I'm just going to go ahead and write this. We're going to say no strong skewness, no outliers, no reason to doubt the population distribution is approximately normal. Definitely make sure you say approximately normal. It's not normal, it's approximately normal. All right, so on the calculator, I did not do this if you watch my other videos, which was really dumb. I have everything already pre-typed in, but here I do. So stat edit, and I've typed in the numbers. You can pause and go do that right now. You definitely want to plug these in the calculator though. All right, and then we're gonna go stat test and then t-test. And we got all the information from that last one. So this time, mu naught is 1,000. Oh, and I'm sorry, we're on the data one. That's not very good. But good, it already switched my mu naught to 1,000. The list is L1, and we're trying to check to see if our bulbs are less than they're supposed to be. And there's our answer. Okay, now also, by the way, we don't have to put this in the write-up, but it is sometimes nice to see that the X bar, that's the average or the mean of these 14 bulbs. So it was under 1,000, but not by much. And look at that standard deviation. It's a huge standard deviation. I made that on purpose because we got insanely, these bulbs